Hi, in this video I am going to go through and make some timers. Very simple things, just counting down. Why I'm doing this is to demonstrate how to use for loops, as well as then how to write a function, as well as how do I then kind of like riff? How do I jazz my yeah, let's go. You know what? No, this is the final take. I'm not doing this again. All right? Final take. I don't care if I just said I'm going to jazz this function. That's what we're doing. You ready for this? Let's go. All right. To start off a function, we got to decide what is this function going to do? Like, what is its inputs going to be? Like, how is it going to work? And then, like, once you've kind of made those decisions, then you can just write the code. And that's where I'm like saying you should start with it for any function of significance. Like, you know, something simpler than just some short math. Anything more exhausting than that, really focus on the code first. You know, clear your environment, make yourself some test values. So here I want a function where it's kind of going to start off in minutes. So my input, and let's just call it time. Let's see, is time something that time exists? So let's just call it time1. Or how about targ, like targ. Oh, you know what? I said it right there. I'm defining it as time, but really you can call it whatever you want. You should actually generally avoid anything that's already got a name, but I guess in this question I did put time, so let's just do that. All right, next up, we're going to give it some test values, just something easy. I want the time in minutes, so that's going to need to just be length 1 because the idea is that that's how long this timer should go. Why would I have multiple times? Maybe that's a function I could add later, but for right now, let's just keep it simple. So, I don't know, like 10 seconds. So 10 seconds in minutes is 1/6 of a minute. And so now I have a test object. There it is. We can see it, 0.16 repeating. We have a starting value. Now let's hash out that code. Now, this is where a lot of experience is going to come in. You're going to see me move very quickly here. I'll be honest, like this is a skill I've built over time. But one of the things, sorry, one of the things that I think helps is just kind of having gotten used to for loops and like knowing anytime I want to repeat a process, I'm wanting some kind of loop, at least most of the time. For simple math, that's not true. R is already vectorized for math. So like if I just want to do something like this, I can multiply it by 2. And that's just going to repeat for every value. Math is already vectorized, but something like printing is not. And especially if I then want to like separate that printing by time. So as long as my timer doesn't need to be super precise, what I can do is I can just say something like a for loop. And I'm just going to keep it simple. I'm just going to do I. It doesn't have to be I. It could be whatever I want it to be. But I'm going to say I in... well, we need something here. So what the for loop will do is it's going to make an object that's described on the left side of the word in. And there does have to be a space there. It is going to set that object to a different value each round of the loop. And that value is going to come from whatever goes here. And that also, this whatever goes here, is used to determine how many total loops there are. And it's based on just the length of the object. So for example, if I wanted this to repeat 10 times, I need to give it a length 10 object. So let's try to make that. Loop vec. So loop vec, which is going to be the vector I'm looping across, I'll make it from time because if I do that, then all I have to do is change the value of time in order to change, to the power of 60. Times 60. Then all I have to do is change what time is, and this will just keep working. And I'm just going to say through 1, because what I'll want it to do, and I'm doing like a trick here, is I am going to make it so that the first round of this loop, I is going to become the first value in loop vector. And based off of this math, that's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Timer's done. I can test this out. We'll just add a print message, or you know what? Let's get fancy and add a message function. And we're just gonna message I. So we're just gonna see what is I every time it runs. Now, the problem is right now there is no object called I because that's what the for loop does. It actually makes I, and every time it runs the loop, every time it reaches the end and starts back over, it makes I again, but using the next value in whatever was over here. So the first time it makes it, it's going to be 10. Then it's going to be 9, then 8, and then 7, then 6, and then 5, 4, 3, 2, 1. And I want you to think what that's going to do when I run this. And hopefully what you expected is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, but very, very fast. Too fast for us to see, and certainly too fast for our timer. And so a common trick in order to see what's happening in a loop beyond simply creating an object of I and like setting it to each value in order to manually run the stuff inside is you can slow it down, sys.sleep. And the nice thing about sys.sleep is it allows us to also watch what's going to happen with our timer. So if I run this now, again, predict what's going to happen. 9, 8, 7, 6, 5, 4, 3, 2, 1. And then the loop is done. And if there was anything else, so if I had said like print, oh, let's just change it to message again. Done. I got a broken keyboard, so I'm having trouble a little bit here. Yeah, so that's gonna now work, and when it's done, it's gonna print off message. So pretty good so far. I have the code. I could clear my environment. I could test it again just to be sure. Still working, looking great. At the end, it'll print the message done. I said make a function that is a timer. So this isn't a function yet, so now we'll need to make it into a function. And really the biggest mistake I see students make at this point is they leave stuff like this in, which was where I was making some test values for the code. But I want that to be a variable. Like that's the point of making this a function, is that it becomes flexible. So I'm just going to call it myTimer. I think that's what I called it later on. It's going to have function, and then the argument inside is time. So whatever I put between the parentheses for the function, that's what I'm able to change from the outside of the function, which is the idea. You're like kind of isolating a process and making it replicable and iteratable, all that fun stuff that lets you do science. So now that I've run this, I can see my function. I'm going to clear my environment again, though. I'm going to run it just so I can be confident that I've written my code right and I'm not accidentally using something from outside the function. Or like from a previous version. Because this is one of the quirks of R, is that its scoping rules is the term for that, is that if inside of a function it can't find an object, it expects to be able to find, it looks upwards to the parent environment, which in this case is my global. So like if I had accidentally like misspelled time, but I had on the out, like if I had misspelled this, so it was like time, and I had an object called time in my global environment, it would find time in my global environment because the only object inside the function at that point would be called time. And that's not going to work, or time, I guess. Anyways, that's not what I did. I don't remember if I just ran that, so I'm going to run this again, just make sure I have an up-to-date version of my function. And now let's try it out. Let's do even shorter. Let's just do 5 seconds, and if we did it all right, we should be close to done. 5, 4, 3, 2, 1, done. Looking good. So that's it. That's simple, quick, and fast. If all you're interested in is like, how could I get the basics of function writing in R, that's the basics. I guess the only other thing is oftentimes, at least in my class, I suggest that students add functions to a standalone file. And there's a lot of good reasons for that. And the big reason, though, that I like to talk about is timer.r. We'll just call it timer.r. The big reason I like to talk about is it allows us to use the debug mode session. And that's where we like come in here, we click over here, and then we click source on save, and then we save it, and we now have a debug timer. And the reason you do that is that with the debug timer, you're able to like get inside the function and see its environments, not your global environment, but what it's going on the inside. But I already have a video on that, so I'm not going to keep doing this. I'm going to back out and kind of show you the more conventional way. I don't even know it's conventional. The debug tool is great, but it does take some learning, so I'm going to back off of that. Go watch the other video if you're interested. Okay, so what I just did is I undid the debug mode, so I declicked that, and then I sourced it again. This time the source, though, is just this clean source. Okay, next up, let's start riffing. Let's start coming up with new ways of writing this code. So this time I want to have, I want to have two arguments. One argument should be time, one should be unit. That time argument is going to be time in seconds, minutes, or hours. That's going to require me to do some comparisons against this unit argument and then determine does the user want me to do calculations for seconds or minutes or hours, and then adjust the timer from there. Now, as I was scrolling down, I did notice I forgot to do one thing with my function, and that was I asked you here to add the systime as the returned data. But we'll, well, I guess I can do that right now. So like I say, really focus on small steps at a time. Right now, my function doesn't have a systime. Well, let's add a systime. It's easy enough. Let's just copy this. The way systime works, if you're not familiar, is it returns the system time. Not very hard. I wanted you to return that data, which means using the return function. There's a lot of ways to return data. I want you to use the return function, not necessarily because you have to, but because it makes the behavior a little bit more predictable. It means that, let's say I am running the function. If I don't assign it, it does print something off at the end, and you'll see this. So when the function returns it, it gets printed out. Without that return function, so if I take that out and resource it, and let's just make this even smaller because I don't have to wait 5 seconds. Oh, well, it did print it. And there we go. It makes it less predictable. Had I think, let's see, if I had done like some extra code down here, I think in this situation I wouldn't see that printed. But like I said, it's really, I like to have you use return because it makes it predictable. There we go. When I had code after sys.time, even if I wanted that to be what was returned to the user, this code is suppressing that from being printed at the end. And it doesn't even print X, it just prints nothing. And weirdly enough, if I assign this to something, oh wait, not that, output. Well, it turns out the thing that got stored in out was X. And again, just confusing. So generally, I always recommend you use return in order to make that much more predictable, or at least predictable to students who just don't have quite a bit of experience, much experience. In general, though, it returns the last thing, but not always the last thing. Okay, let's go through timer 2. So timer 2, we're going to add some new abilities. Don't know what that sound was. So let's just redo that timer real fast again, but this time we're going to add the unit. Now I'm going to repeat the whole process just to kind of help re-explain it, but in the end, what I would actually normally be doing is I might pull this code out of the function, go edit it, play with the code a little bit, and then add back in. Additionally, I might go into that debug mode and edit the code in there. Or I may just edit the function directly, but I really want to strongly suggest you don't try to do that right now. A lot of this does typically take some effort to figure out. So I'm going to do that middle option. I'm going to copy and paste. I'm going to work on the code out here, and then we'll put the function around it afterwards once we've kind of played with it. So anytime you're working on a function, it's going to help to have some test values. So I'm just going to make time that value we were using earlier. So 1.6. And this time a unit. Well, in this case, the unit would be minute. So let's make it minute. There we go. Okay. So now I need to figure out how can I use these inputs in order to do this. Well, the time is already done. Like I have the time, but the problem is this calculation is only right if the unit is minutes. And I hope you notice I didn't actually even intend to do that. So I'm just getting really good at this, but the if I used in that sentence was the trick. So if unit equals, not just one equals, because just one equals would actually create an object called unit set to minute. which actually already exists, so I'd be a little bit confused if I did that. But if the unit value is minute, then do this, because that's the right calculation for creating loopvec if the time is in minutes. If the time is in hours, you would do this, right? So that would be a different test. Now, right now I'm using minutes, but in my question, I did say plural. So we're going to make that all plural. And finally, if it's seconds, well, that one's really easy. No multiplication needed. I think that's all going to make sense to most people. Yeah, I'm just going to move forward from that. I think that's good so far. So now I just need to turn it into a function. So the function is going to be called myTimer2. What's it called myTimer? Who cares? Function time and unit. I believe, yeah, single. Both of those kind of bad names for arguments. Sorry. All right. So I now have a function called myTimer. I could run it just to see, does it turn into a function? Yes, that ran. But I want to test it, right? Like I want to test it from a clean environment. So I'm going to go put this in here. I'm just going to erase my old version, update that. I'm going to source it. So that's that source on save. When I saved it, it sourced the function, overriding was here before. Now, if I didn't trust myself here, I can clear my environment, source on save, it's still there. Cool. So I feel very confident now. Now, I don't want this test data here. I just want to try to use myTimer. I did already have some tests for you. So for example, here, I want time to be 2. I want unit to be seconds, plural. And so, it says error object loopvec not found. So we need to go investigate what's going on. Why is loopvec not being found? Loopvec should have been made. So let's go investigate. So here I have time and I have unit. That looks good. Shouldn't have any issues. I named them when I named it, and it wasn't complaining about the argument name. And then I come into here and I'm like, oh, I see it. I left the unit equals minutes. That was intended to be seconds. So now that I fixed that, I save the function. Again, if you didn't trust the source function, you could erase this, but when I sourced it, it reloaded the newest version, which is why I like to do it this way, right? So I'm constantly saving. It gives me lots of like little checkpoints to go look through. I know, it's kind of cool. It's a strategy. But now I have my myTimer up again. My time is set to 2, the unit is set to seconds, and let's try running it. 2, 1, done. And it printed off the message because system time was returned. Lovely. Let's try this next one. 5, 4, 3, 2, 1. Now these were actually really just testing what was there previously. But this time let's do this in minutes and let's make sure the minutes method is working. Hey, our minutes logic is working. So now we've tested our seconds logic, our minutes logic. The only one left is our hours logic. And this one's also working. Okay, all in all, pretty easy. It just took 3 if statements. Please note, these were not else ifs. I could have made these else ifs and there would be an added benefit. Had I made these else ifs, I could have had a last one which produced an error message and been like, hey, your unit value is not allowed. And that's just a little error message. So that way, if somebody accidentally says, yeah, please give me a 5, oh, let's get one that Nolan would absolutely say because he is a little sloppy with his words sometimes. Give me a 2-second timer. Well, second isn't a value allowed. Seconds, plural, is the value allowed. So that's producing a stop message, and the function exits at that point because it doesn't know how to use my value, so which is appropriate to exit. And that's really this kind of benefit of else, is that it allows us to give kind of a catch-all strategy at the end of some logic. So either way works. This way is a little bit better because it leads us into this next question. which is really just make a function, have the same arguments. Those were actually all fine, but just start adding in like controls, ways to tell, add in these controls, ways to tell the user that stuff maybe isn't working great. So like if the time is negative, can't do that. If the time isn't a number, it can't do that either. If the character value can't, oh, okay, so that was clever of me. So test to see if it's a character, and then test to see if you convert it into a number, is it a number? And is that number positive? Warn the user if the time or unit arguments are longer than length 0. One thing that I've already implemented is a stop function if a unallowed unit has been provided. So let's go start that. Let's just start thinking about it. So thinking about what could go wrong here. Well, one is time. So if is dot numeric time is not true, then we can produce a stop message. I could also, as dot numeric time, and then I could test, is it nah? So in this situation, even if time isn't a number, if it's able to be converted into a number, then my code will actually proceed. So if this is if this is unable to be converted into a number, then I would want it to produce a stop message. So stop time is not able to be interpreted as a number. Okay, now anytime we're actually manually coding inside of a function, you'll notice I kind of took that third strategy that I was talking about earlier, and I'm just jumping right into the function, which, you know, as you get better, you do, but you also have to learn, like, it does place barriers between you. And the biggest one is anytime you try to put a lot of code in, well, any mistake is going to have repercussions. And so we're going to immediately start testing that. So if this is the strategy I'm using, I'm going to immediately jump in and start testing to see if this is working right. So having just sourced this, let's try to see what happens if I try to give it the letter A for time. So I got time is not able to be interpreted as a number. So that was perfect. That was exactly what I wanted. I also got a warning message saying NAs introduced by coercion, which is just kind of nice. That's the warning message produced by as.numeric. Let's see what happens if I put the numeral one, so quotation marks, not the value one. In that situation, it actually worked perfectly, and it should. Like, there's no reason we couldn't interpret that. That's pretty reliably and understandably actually a number, and so that was appropriate. Cool, one check down. Let me just go cross them out so I don't forget that I've done them. If the time is a character that can't be coerced into a value, done. Warn if time is longer than 0 or if time is negative. All right, let's go do those. So if time is less than 0, stop. Must be a positive value. Now, one thing you might be wondering is, well, what happens if time was like a letter? So let's try that. Let's see what happens if I had the character 1 instead of the number 1, and then I had less than 0. So that's false, and it should be false. That's good. Let's try -1, less than 0, and that's true. So even if this is a character, then this logic is still working correctly, and so it's still going to stop the code. So that seems to be working well, even with all the outcomes I can kind of think of would end up reaching this point of the code. Next up, I said if the length is greater than 1. So length of time greater than 1. Now, did I say it has to be length 1, or did I say should warn the user if time? So just warning is implying that the function could continue. So warning, I don't know, I just said warn. Time should be length 1, but it is not. Only using first value. And so then I would change time based on time, and I would just extract the first value of time and overwrite the original one. So in this situation, I'm just picturing that a time that was larger would be like larger in terms of length, would then be trimmed down by extracting from that first position and then overwriting the entirety of the object. Now, I think I just added 2 if statements this time. I'm in real dangerous territory, so I definitely need to save and check things just to make sure that we are making progress and I'm not breaking it. So I'm just going to run through some of my check code. That one's looking good. I've added stuff like what happens if time is long. So what happens if it's something like this? Okay. So in this situation, I'm finding out that one of my logics, because the length of is.na is too long, then it's causing a problem. And so I can go back in and fix that. Now this is really where you have to kind of just start going back and forth and you start to see how they're interacting. Well, it's like, all right, well, if this is possibly multiple values, then I'm just gonna have to say if any, so we'll have to make a decision here. So if any values in that are missing, then you need to stop it. And we can test it out. Oh, I think I had an error message. I did. I have an unmatched bracket. That's usually because I forgot to add a parenthesis. There it is. I needed a second parenthesis. I saved that again, and now we're good. All right, let's go check it again. Error in if time is less than 0. All right, so again, I need that any. Now this time, if you didn't see what just happened, I added an in parenthesis. And the reason why that first time I messed up is that R's kind of detect, or RStudio, I think more likely, is detecting that I already have a parenthesis there, and it's pretending that that's the one I wanted. So instead, I'll need to press it again, adding that second parenthesis, saving it, and now it all looks good. It's sourcing, it's not producing an error. I'm good to go. Now, this time I do believe it'll actually work. Yeah. But I get this warning message that we programmed in afterwards. So it said time should be length 1, but it is not, only using first value. And then indeed, it used the first value. So now I'm feeling good. If I want to do any more tests, maybe something like that, just to see if my innies and my alls are working. Good. So because I used any, it is giving me that stop message that time is not able to be interpreted as a number. And that's coming from this right here. And that's because we used any instead of all. All would not have been true, and this would not have occurred. But any for the first value in this was true, but the second, or sorry, was false, but the second value was true. It did become na in A. And so any returned true. Cool. All right, so we've got a lot of good tests. Let's go through our list again. I got this one. Nice. If the unit is not one expected values, we actually implemented that one at the very beginning. So if you missed that, just scroll back up. And it should warn the user if the time or unit arguments are longer than length 0. So now I just need to go in and add another one for the unit length. Unit, sorry, my length. Unit should be length 1, but it is not, just using first one, and then we'll just actually have to make that happen. And let's save it, check it. Minutes, there we go. And we'll just fix that so it's not going to produce an error message. I don't see any other issues. Oh, I do see an issue. I'm missing a parenthesis. I usually have auto parentheses turned off, but I don't right now. All right, so in this situation, we got 2 warning messages. We got one that time should be length 1, but it's not. And we also got that unit should be length 1, but it's not. But in both cases, it did continue going forward using that first value. So that's all working great. And I believe I'm actually done. Just scrolling through these to make sure I didn't forget anything. No, that's looking pretty good. So I could go through the rest of these test case scenarios. Obviously, I made up some up here, so there's plenty more test case scenarios that you could do, but just checking through these. 5, 4, 3, 2, 1. I'm going to make these shorter. I don't want to have to wait 5 seconds each time. 32. Done. 32 again, I guess. I don't know. Done. Oh, your unit's not allowed. That's appropriate. Second is not an allowed value. -5 is not an allowed value. The word 5 is unable to be coerced into the number 5, unfortunately, and so that's also not allowed. This is all working pretty good, and I'm feeling done. I now have a script file. I can clear my environment just to triple, double, everything check. Source this. Still working. Excellent. The rest are working too. So there was no more issues, but that's really the process. Just keep testing it constantly. And really, when you can, focus on writing the code outside of the function, because putting it in the function does add a barrier between you. Not impossible, and I personally code a lot in the functions. I code especially a lot in the functions when I'm using that debug mode. But that's where I say, go check out my video if you really want to lean into using debug mode. All right, I hope that helped, and have a good day.